Station, this is Houston. Are you ready for the event?
We are ready.
Houston ACR, this is Mission Control, Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
We have you loud and clear. How do you hear me?
We have you loud and clear as well. Please stand by for a voice check. Please stand by for opening remarks.
Hi, I'm Jacob. What's it like to be an explorer of the cosmos, representing all of humanity?
Hi, Jacob. It's a huge privilege and honor, and honestly, it's a lot of fun. We just arrived here a little under a week ago, Tom and I, who joined Mark, who's been up here for 6 months, and it's honestly the coolest thing I've ever done. It was so fun to float through the hatch into the space station, and I'm so excited for all of the amazing science we're going to be doing over the next 6 months as part of Expedition 66.
Hello, I'm Congresswoman Bernice Johnson, proudly representing North Texas in the U.S. House of Representatives. Today, I am very excited to introduce our Dallas area students to the Expedition 66 crew, currently aboard the International Space Station. I also want to welcome all those watching on NASA TV. I'm looking forward to all we will learn today, and I would like to thank those at NASA and the crew for making this event possible. Now for our first question.
Hi, my name is Amaria. My question is, how would you describe going to space and being on a different planet to a middle school student who dreams of being an astronaut?
Station, this is Houston ACR. The microphone is not turned on.
Maria, I'm back with you. That's a great question, and I'm hoping that you can go to a different planet and visit there and come back and tell us what it's like. But coming into space, as Kayla said, is an absolutely wonderful experience. It's completely different from anything on Earth as we try to adapt to living without the effects of gravity. But living in a spaceship is wonderful. The view of the Earth is wonderful. And I can't wait to hear what you say about visiting another planet.
Hi, I'm Destiny. Do you believe that mankind will be able to visit other solar systems?
I think humankind has the ability to do amazing things, and we've always been surprised by the things we've been able to accomplish. So I fully expect that as long as we are able to keep the planet healthy for us to continue living long enough there, then I think we'll be able to do that.
Hi, my name is London Jackson, and my question is, how do you feel about humans colonizing the moon?
We are really excited about the return to the moon here at NASA. You may have heard about the Artemis program, which is our program that will return human beings to the moon by 2024 is our goal. And this time, unlike Apollo, where we just got to visit a few really interesting geologic sites, this time we're going to stay. We want to build habitats on the moon, we want to generate power, we want to harvest resources, and we want to do some incredible science. And the moon is the perfect place for us to develop and test all of the technologies that we'll need to eventually stand on another planet by going to Mars. And so Artemis is coming. We're getting ready to launch the first uncrewed test flight of the Orion capsule aboard an SLS rocket here pretty soon. So we might even get to see that launch from the space station windows, which would be pretty epic. So I think going back to the moon is going to be an awesome opportunity to do some incredible science and engineering work.
Hi, my name is Candy Cash. My question is, can we use dark energy as a power source?
Candy, that's a good question. And you know what? I don't know the answer to that. And that's okay. It's okay to not know. because I'm hoping that you can study physics, or somebody can in your class, and figure all that out for us. We do need another energy source. So dark matter is a fascinating thing. On the space station here, we have the largest power supply in the world that's feeding this particle detector called AMS that is actually looking for the presence of dark matter and figuring out how much there is of it. So that's a great question, and again, looking forward to seeing what you find out.
Hi, my name is Anaytaran, and my question is, what is escape velocity and what alternative can be used if it is not achieved when putting a vehicle in orbit?
So I think what we're actually talking about is a velocity that will escape the Earth's surface and get to orbit. So I'm gonna redefine that a little bit as an orbital velocity, and basically what that means is you've got to go fast enough, just like if you throw a baseball. If you throw a baseball, it's going to land back on the Earth, but you got to throw it, whatever it is, a rocket, some object, fast enough so that it keeps missing the edge of the Earth. And what we're doing on the space station is we are actually constantly accelerating, just like you are. If the ground wasn't beneath your feet, you would accelerate towards the center of the Earth. We are accelerating towards the center of the Earth all the time. We just keep moving so fast horizontally that we keep missing the Earth. So that's what I would call an orbital velocity. And of course, if you don't achieve it, you need to find a way to get there. If your goal is to get the orbital velocity, so that means you need some more thrust.
Hi, my name is Journey Blue Roberts from Kennemer STEAM Academy, and my question is, what are the key differences between the gravity here on Earth and the gravity in outer space?
Yeah, that's a good question to build off the last one, actually. In outer space, we still experience gravity. The pull of the Earth is what is keeping us in orbit. The difference is we don't have the solid ground of the Earth underneath us to hold us down. The station is free falling around the Earth in its orbit, and so are we and everything inside it at about the same rate. That's why we can float and pick up our feet and float. We have the ability to basically feel like we're flying. So that's the difference, is we're in free fall more or less, as opposed to on Earth where you're stuck on the ground.
Hi, I'm Sarah. Does getting used to gravity again get easier after more trips?
It actually does. I flew in space on a short duration flight on the shuttle, and gravity was really tough. It made me feel sick. I felt very weak. I felt like this big magnet was pulling me down to the ground after my flight. When I came back from my first long duration space flight, it still was very hard to get used to gravity again, but it was a lot easier. We have great exercise machines up here. We've learned a lot about taking care of humans in space, especially for long duration. So it does get a little bit easier, but our technology gets easier, better as well, to enable us to come back to Earth, because ultimately that's what we want to do, come back to Earth and readapt to Earth life.
Hi, my name is Kennedy. My question is, how far have you all seen or gone into space?
So how far have I traveled in space? I do not know the exact answer, but I'll tell you what, I got a great word problem for you all to do. So if you figure out the radius of the Earth and add about 240 kilometers to it, that'll give you the radius of the path that we're all traveling on right now. And if you multiply that by 2 pi r, you get the distance we travel every time we go around the Earth. And we do that once every 90 minutes. And I've been doing that for my entire astronaut career. I think this is the 391st day. So with that information, you can figure out the distance I've traveled in space.
Hi, my name is Cherish. My question is, where is the edge of the universe?
That is a tough scientific and even philosophical question that the smartest minds on our planet are still debating. Nobody's quite sure if the universe is finite or infinite, if it's flat or curved, if it has an edge, and if it did have an edge, what's beyond it? Presumably, if you decide everything's part of the universe, even nothing is something. So that's a really hard question to answer, and I think I'll leave that to the bright minds of the astrophysicists and cosmologists who are studying that on Earth.
Hi, my name is Zuri. My question is, does it take more time for an astronaut to reach space or more time to come back down to Earth?
That is a great question. It takes a lot more time, actually, to come down from space to the Earth. And the reason for that is to get into space, we need these huge engines to get out of the atmosphere, get high enough to get that speed that Mark was talking about, so it goes sideways to stay in orbit. We can't carry up big rockets with us to get us back down again, so we bring just a little rocket in the back of our spacecraft. It slows us up just enough so we start falling back to Earth, and then we let hitting the atmosphere take care of all the rest of the deceleration that we need. We get a lot of heat. We actually become a little meteor inside of our spaceship, and our heat shield protects us, but that's all that friction that's slowing us down. And then finally, when we come out from that entry phase, and we're in the atmosphere, parachutes open, and we have this very nice little gentle descent down to the ocean. So a lot longer to get back to Earth.
Hello, my name is Ewell Johnson, and my question is, what will you all do differently on Expedition 66 that you did not do in previous missions?
Gosh, there's so many things, but the thing that I was most excited about is I actually got to harvest about 8 hatch chilies, and not just harvest them and put them in a freezer like so many of the other interesting things that we grow up here so that we can do research on it later, but we actually got to eat these hatch chilies. So we added them to our food, and it was really, really exciting.
Hi, my name is Eric Robles, and my question is, what technological advancements are being made that will make this expedition more efficient than the last?
We are doing some amazing science up here to figure out how to make our time more efficient, but also use our resources more efficiently in space, which is really important because we only have what's up here with us. And if we need something new, we have to send it from Earth, and that can take a while. And as we continue on exploration missions to the moon or eventually to Mars, that challenge will become even more serious. So one of the things we're doing right now is learning how to be more efficient with our reclamation of water. Right now, the space station, we get about 90% of our water back through reprocessing, and we're trying to get that up to around 99% for planetary missions to the moon and Mars. So we have a system called the Brine processing assembly that we're using right now to try to see if we can get just a little bit more water back out of what we process through our bodies. So we're doing things like that all over the space station to try to understand how we can be more efficient with our resources.
Hi, my name is Isabel, and my question is, how do you think that your work on the space station has benefited life here on Earth?
Boy, there's so many ways that it's benefited life on Earth, and so many ways to answer that question. It's almost hard to know where to begin. The kind of work we're doing here is groundbreaking. So that means, like the AMS up there, trying to discover dark energy. That's something that could affect all of us 50 to 100 years from now in ways that we just can't even imagine. That's true of a lot of the experiments we do. We're seeing things that human beings have seen for the first time ever in this microgravity or zero gravity world that we live in. So the benefits are going to accrue over time, not to mention the enormous amount of engineering brilliance that goes into developing a space station, solving these problems. Those are all engineering solutions that come back to Earth and empowers our industry. There's all kinds of fluids experiments, metal experiments, liquid metal experiments, colloid experiments that are going on that are applicable to completely to industry. I'm a doctor, so I am particular to the kind of medical research that we do. And a lot of our work has been done to improve medical care in remote areas of the Earth, which could be in an inner city, or it could be in a country or a state, a land that's far away from any big medical center. So there's all kinds of things that are going on here that benefit life on Earth.
Hi, my name is Blake. My question is, do you think space travel will be your normal outing in the next 30 years?
I certainly hope that we can find a way to make it as possible for the average human to do as air travel has become. I hope that we can find a way to make it something that is less resources intensive and something that makes travel quickly accessible for all kinds of people. So I certainly hope so. In the next 30 years, I think we're already making great strides in that direction, certainly as we grow a stronger and stronger commercial enterprise in low Earth orbit.
Hi, I'm Sean. How do you envision the future of space travel?
I envision this future of space travel as something that's available to so many more people than it is right now and so far. And I think we're seeing the dawn of that new era where it's accessible to more people. And I think we're going to go farther and longer than we ever have before, certainly in NASA missions.
Hi, I'm Jillian. Was it always your dream to become an astronaut?
Joanne, when I was real little, I was very fascinated with space, and I've always loved space. I, however, became interested in math and science, largely because of my interest in space when I was about 13 years old. I would have loved to have flown in space. I would have been thrilled by it, but I just didn't think I could ever become an astronaut. But I went ahead, and in the hopes of working for NASA someday, I got an engineering degree and went into medicine. And then suddenly I got a job at NASA and found out that I could indeed become an astronaut, and so I applied and I got it. And so what I think that means is that what I did was I did something that interested me. I had a long-term goal, but I was doing something at the moment that was interesting and useful to me, engineering and medicine. And sure enough, my preparation met the opportunity, and suddenly I found myself becoming an astronaut.
Hi, my name is Michelle, and my question is, according to the NASA website, the military provides a specific list of personnel who qualify for the astronaut training program. What degrees and/or qualifications did you have and/or need when you applied for the program?
So the current requirements to become an astronaut are, first of all, to become a NASA astronaut, you have to be a U.S. citizen. You've got to have a master's degree in a technical field, mathematics, physical sciences, medical science. And I'm not sure about this. I think there used to be a 3-year experience requirement and a requirement if you were a pilot and wanted to go that route, you might be able to have less than 3 years of experience, but you had to have something like 1,000 hours of pilot and command time, which is very hard to do that quickly. So challenging. We've gotten lots of great applications, and there's thousands of people that are well qualified to do that job that don't get the opportunity. So I would encourage everybody to find something you love to do, because if the path to becoming an astronaut results in becoming an astronaut, that's great. But if you're loving what you're doing on the way, then you'll be really happy regardless of the result.
Hi, my name is Austin Bailey. My question is, what was the most valuable lesson that you've learned that has prepared you to become an astronaut?
I think the most valuable thing I learned that has helped me as an astronaut is how to be a member of a team. I've learned that through athletics, through being a member of my family, through participating in a lot of different activities, and through, in my case, serving in the military, in the Navy and in the submarine force. Going to space is something you need a really strong team to do, whether that is, in my case, the SpaceX team who launched us here aboard a Crew Dragon, the NASA team who's in mission control 24/7 supporting the operations of the space station, our incredible scientists who support the experiments we do here, and of course our crewmates who help us through the hard times and keep us focused on the mission. So I think that's the most important skill you need to develop if you want to become an astronaut.
Hi, my name is Tari. My question is, how do you prepare yourself before you have to fly into space?
Actually, I would say I started preparing myself for my first space flight when I started school in first grade. And it's very important as an astronaut to learn a lot. You have to learn all kinds of things, so you kind of have to learn how to learn. We came up here on the space station, and we're learning things every day. It's a very complex environment, and it's impossible to predict what's going to happen. So being able to learn how to learn and is very important. So I would say that all of you are preparing, if you want to become an astronaut, preparing right now at school, taking care of yourself, learning how to work as a team, as Kayla was mentioning. That is all absolutely essential, and it's never too early to start.
To our students and all those who are watching at home, I hope you have found this event as inspiring as I have. Maybe one day it will be you talking to students from space. We've learned a lot today, and I want to again thank NASA and Expedition 66 crew for your time, your service, and for this incredible experience.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants. Station will now resume operational comm.